So we've got a few more examples with rational functions. The first one says name the intercepts, domain, vertical asymptotes, and discontinuities of this function. So we're kind of putting everything together from this section. We're again going to start by factoring the top and the bottom. So notice the first is a difference of two, or the top is a difference of two squares, which will factor into x minus 5 and x plus 5. And then the bottom, if you factor it, that's going to give you, I need factors of 15 or negative 15 that add to be negative 2. So to get the negative 2, I would need a negative 5 and a positive 3. So if you foiled that back, you would get negative 5x plus 3x to give you the middle term, which is your negative 2x. And then the negative 5 times the positive 3 will give you the negative 15 at the end. So that factors into that. And then notice you've got a factor of x minus 5 on top and bottom. So that will simplify to x plus 5 over x plus 3. So do that first and then start answering the questions. I'm actually going to start with domain first, because when you do the domain, you're looking from the problem spots from the beginning function before you've simplified it. So on a rational function, that's going to be when the denominator equals 0, will give you your problem spots. So x squared minus 2x minus 15 cannot equal 0. And we've already factored that into x minus 5 and x plus 3. So what that tells us is x equals 5 and x equals negative 3 are problem spots. So it can't equal 5 and it can't equal negative 3. So that's our domain restrictions. Then we can, let's do the y-intercepts next. Y-intercepts are always the easiest to do because you're just setting x equal to 0. So if I have f of 0, that's going to be 0 squared minus 25 over 0 squared minus 2 times 0 minus 15. So everything with an x will zero out, and that leaves us with negative 25 over negative 15, or positive 5 over 3. So you have a y-intercept at 0, 5/3. And then your x-intercepts, remember in the earlier section, you just have to set the top equal to 0. And you can actually just set the simplified version, the x plus 5 from the top equal to 0. That's going to give you your x-intercept of x equals negative 5. So at negative 5, 0, you have an x-intercept. So on the x-intercept, you can use the simplified version and set the top equal to 0. So we've done the intercepts and the domain. Now let's talk about the vertical asymptotes and the discontinuities. Remember from the previous section, if you have a factor that cancels out, that's going to be a discontinuity. The one that doesn't cancel out is going to be a vertical asymptote. So here we're going to have a vertical asymptote at x plus 3 equals 0, which would be at x equals negative 3. So that means the graph will approach it, but it won't ever cross at the vertical line x equals negative 3. And then we're going to have a discontinuity at x minus 5 equals 0, so at x equals 5, you will have a discontinuity. Now that means there'll be a hole in the graph right there. Now if you want to know where that is, where it crosses at x equals 5, so basically looking for the point, if you plugged 5 into the original equation, you're going to get 0 in the denominator because you would have 5 there and 5 there, and it would end up zeroing this out. So instead, if you plug it into the simplified version, you'd end up with 5 plus 5 over 5 plus 3 would equal 10 over 8, or 5/4. So there's going to be a hole at 5 and 5/4, or 1 1/4. If you graph that, it might not show up to the visual eye, but there would be an error right there. So it would go up to 5 and then jump over it, creating the hole. Okay, our next example is you're going to write an equation for a rational function with these given characteristics. So rational function means I've got a fraction. I'm also going to have some a multiplier out in front, or you can put it on top of the fraction, it doesn't matter. But that's going to tell you how it's vertically stretched or shrunk. There'll always be an a right there. And then from the characteristics, I know I have a vertical asymptote at x equals -5 and x equals -3. Remember, vertical asymptotes is where the denominator equals 0. So these are going to go, you need to rewrite them as factors, but they're going to go on the bottom of your function. So that x equals -5 would be a factor of x plus 5. And then x equals -3 would be a factor of x plus 3. So they go on the bottom because they're vertical asymptotes. And then the x-intercepts are going to go on the top. Remember, to find x-intercepts, you just have to set the top equal to 0. So writing them as factors, I'm going to have x minus 3 and x minus 4. So I have a function, a rational function right there, but I don't know what a is yet. And that's what I'm going to use the y-intercept for, is to find a. So the y-intercept is the point 0, 2, where x is 0 and y is 2. So I'm going to plug 2 in for y, or f of x, equals a, and then I'm going to plug zeros in for all of my x's. And this is going to allow me to solve for a, because I've plugged in numbers for every other variable. So I've got 2 equals a times, that's going to be -3 times -4 will give me a positive 12. And then on the bottom I have 5 times 3 is 15. So you can solve this a couple different ways. I'm going to multiply by the reciprocal of 12 over 15. So I'm multiplying by 15 over 12. That'll cancel out my 15s and cancel out my 12s on the right to leave me with just a equals 15 times 2. So 30 over 12 times 1. And that will reduce to 5/2, because 6 will go into both of those. So my a is 5/2, so I can write my function now as 5 over 2, and then put in my x-intercepts and my vertical asymptotes. So this is a rational function with those characteristics. It's not the only one, but it's a rational function with those intercepts and vertical asymptotes.